Now, this graph is recording to study the property of conductivity, means like in the human heart, in the case of the frog's heart too, there is a pacemaker, and that pacemaker, see, cardiac muscle, they have got the property to generate their own impulse, whether it is of the pacemaker or the atria or the ventricle. But pacemaker, why the pacemaker is the pacemaker, why it is the boss? Because it has got the maximum frequency, at the maximum rate it generates the impulse. Say one is generating the impulse at 100 beats per minute, the second part is generating at 70, the third part is generating at 30. So, which one will be the boss? Who will control? The 100 one. So, 101, I am just giving the example like the 100 is not the exact number. So, higher the number of the impulse generation will be the pacemaker. So, in the case of the human heart, SA node is the pacemaker, right. So, from the SA node it goes to the atria, then it goes to the ventricle. It means there is a property of the conductivity. Impulse is generated at one place, one part of the heart, and it controls the entire heart's cardiac muscles contraction rate. So, it has to go through the entire cardiac muscle. So, that is called as the conductivity, right, property of conductivity. So, how we will study the property of conductivity? First and foremost thing is, in the case of frog's heart, this one pacemaker is not SA node, it is sinus venosus. Sinus venosus. There is no need to go into detail where exactly it is located, because you are going to become doctor of human being, not of the amphibians, not the veterinary doctor, right. So, just a brief overview. Just imagine, say this is the atria and this is the ventricle, okay, and in the case where exactly is the sinus venosus is like this way. So, just imagine this sinus venosus, it is located outside the atria and the ventricle. The impulse will get generated over here, then it will go to the atria, from the atria it will go to the ventricle, right. This is the direction, okay. So, whatever the rate is generated in the sinus venosus, that is called as sinus rhythm, and the atria and the ventricle of the frog will contact at that rate only, okay. Sinus rate we can call it, sinus rhythm, okay. And if we block the conduction from the sinus venosus, this part to this green part, if we can block by tying, how we will block? By tying this part, in the connection part, the junction of sinus venosus with the atria, we will tie a knot over here with the help of the thread, and that is called as Stannius. Stannius is name of the scientist, ligature, okay, Stannius ligature. So, if we tie that thread in between the sinus venosus and atria, it means whatever the rate has been generated in the sinus venosus, it will stay over there, it won't cross over to the atria. So, the next in line is, who has got the highest apart from the sinus venosus? Atria has got the highest rate. So, then after some time it will become the boss, and the entire of the heart will contract at the rate of the atrial impulse generation, right. Now, if I said from the sinus venosus it goes to the atria and then it goes to the ventricle. So, if we tie the second thread in between this one, say this was the atria and this was the ventricle. So, in between the atria and the ventricle with the help of the third thread, that is called as second Stannius ligature. It means the impulse generated in the atria, it stays in the atria, it won't cross over to the ventricle. Now, the ventricle which has got the lowest rate, after some time it will contract at its own rate. The important thing is, we are recording the contraction of the ventricle. Initially, the recording of the contraction of the ventricle was same as controlled by the sinus venosus. Then we tied a ligature in between sinus venosus and atria. So, the rate of the contraction of the ventricle was controlled by the atria. Now, we have tied the second ligature in between the atria and the ventricle. So, now ventricle will contract at the rate which will be generated by their own. Okay. So, that is the Stannius ligature 1 and 2. Now, let us see at the graph. Let me enhance it. See, if we look over here, this is the normal cardiogram. Okay, now you will get the graph like say one arrow marked over here. It won't be written over there. Otherwise, you will easily catch it. And then there will be second arrow over here. So, what you are seeing the effect? You tied a thread in between the sinus venosus and atria. Okay. So, what happened immediately? Immediately there is, it got stunned. Like what happened? Arey kya ho gaya ab? So, it will take some time, few seconds, and then because it will take some few seconds to understand what has happened and to respond to it. So, at this point it started responding. Now, there is regular impulse generation, right? But what you can see, the rate is reduced as well as height is reduced. So, this was the sinus rhythm, and now this is atrial rhythm, because we have tied the thread in between sinus venosus and atria, that is called as first Stannius ligature. So, you can say the first Stannius ligature has been applied over here, which has resulted in the stoppage of the conduction of impulse generated in sinus venosus to the atria. So, atria will generate the rhythm and the ventricle will contract at the rate and rhythm generated by the atria. So, if we look over here, there are the 5 millimeter in between this one. So, if we count for the 25, 1, 2, 3, 4 and 5, 25 millimeter is this much. So, how many cycles are completed? Only 3 cycles are completed, and 25 millimeter per second is the speed. So, we can calculate the heart rate. So, in 1 second there are the 3 beats, but before the application of the Stannius ligature, 1, 2, 3, 4, 5, this is the 25. There is 1, 2, 3, 4 and 5 completion of the cycles, right. This was the 5, it has got changed to the 3, it means the heart rate is reduced, height is reduced, it means the force of contraction is also reduced. Now, see, the force of contraction is immaterial over here, forget about the force of contraction, because we are just studying the property of conductivity. Okay, so it should be, our focus should be on the rate only. Okay, now we have provided, you will be given the graph with second arrow. Now at this point we provided the second Stannius ligature. So what you can see over here is, if we look over this, one second, let me, you provided the second Stannius ligature, means you tied the thread in between the atria and the ventricle, and what will happen to the ventricle? Ventricle will get confused. Like first he said, okay, there was a regular rhythm, then slower rhythm, now no rhythm at all. So it will take some time to respond it, contemplate the thing, and ultimately it will contact on its own. कहेगा छोड़ो यार, हम खुद ही contact कर लेते हैं. So there will be ultimately generation of the one rhythm. This is called as idioventricular rhythm. See, why I said forget about the height. This has got the more height as compared to this one. So the height, it depends on, because it has stayed static in the diastole phase, it didn't contract. So it got filled up with the blood. And if you look at the Frank-Starling law, there is more and more initial length. So that's why the height has. So forget about the height in this case. Don't comment on the height, just comment on the rate. And this rate, if we continue to taking the graph, after very much time there will be second rhythm, then the third. So it will be slower than the atrial rhythm. So you have got 3 rhythms: sinus rhythm, atrial rhythm and idioventricular rhythm. So that's the regarding the property of conductivity. So how will you go with this graph? Comment on the graph. This is frog's cardiogram showing the property of conductivity, right? And how will you say this one? So go for this one. This is ventricle systole, diastole, atrial systole, diastole. There is a normal regular rhythm. Then at this arrow we have provided something. That something is, we have provided the ligature, that is the Stannius ligature. Okay. So what all the questions you can get, like what is the Stannius ligature, why we apply, we know to study the property of conductivity. Wave of depolarization is not conducted when the ligature is applied due to the mechanical pressure. Pacemaker, what is the pacemaker? Pacemaker is the tissue which is capable of initiating the repetitive action potential. And what is the pacemaker in the case of the frog? It's the sinus venosus. What is the pacemaker in the case of the human being? Because ultimately we are doing all these experiments to correlate with the human being. Okay. So SA node is the pacemaker in human. So can we study the conductivity, property of conductivity of the cardiac muscle in human being? Can? Yes or no? No, we cannot do. Why? The reason is SA node, it is located within the heart, atria itself. So how will you separate it out from the atria? In the case of the frog, the sinus venosus is lying outside, right? So this cannot be done on the mammalian heart, not only on the human being, as the pacemaker tissue is present inside the heart, not the outside of the heart, as in the case of the frog. Sinus rhythm is faster than the atrial rhythm, which is faster than the idioventricular rhythm. If examiner asks you like how will you differentiate them, sinus rhythm, atrial rhythm and ventricular rhythm? Sinus is generated because of the pacemaker and the rate. Sinus rhythm rate is 360 beats per minute. 36, not 360, 36 beats per minute in the case of frog's heart. Atrial rhythm is 24 beats per minute and idioventricular rhythm is 12 beats per minute. So that's all regarding the property of conductivity.